This is chapter 5, problem number 10. The lucky number for this problem is 0. That's your lucky number. Okay, so a bucket of mass 2 kilogram. Okay, so I have a bucket like this. It's hanging with a wire. Okay, so it's going round and round like this. Okay, so the radius over here is 1.20 meter. Okay, so you swing it round and round. Okay, and by the way, by the time when it goes to the top, then of course it will feel lighter than when it goes down here. So if the cable would break, when will the cable break? The cable will break when the bucket sits in the bottom. Imagine that your hand is here, you have a cable making it go round and round vertically. Okay, all right, so this is 1.20 meter. Okay, and when it go to the bottom, it feels 25 newtons. Okay, so let's look at the free body diagram. When it's in the bottom, what happened? Okay, so over here, so it will feel the heaviest is over here. Over here, it feels the centripetal force that creates it, and plus the weight. Okay, so it will be centripetal force plus the weight, that is mg, altogether that will be equal to 25 Newton. Okay, so just by looking at here, so what is my centripetal force? It will be equal to 25 Newton minus m, that is 2 kilogram, times g. G is 9.8. And if I calculate this, I have 25 minus 2 times 9.8. Okay, 5.4. Okay, so this will be your centripetal force. Okay, all right, so now let's get back to our magical formula. Acceleration, that's equal to v squared divided by r. Okay, according to Newton's second law, F, centripetal force, is equal to m times a, centripetal acceleration. You can put a little c over here. Okay, so what is my velocity then? So that is equal to m times v squared divided by r. Okay, so velocity is equal to v squared is equal to centripetal force times r on both sides, and then divided by m, and then take a square root of it. Okay, so it is equal to 5.4 times r. R is 1.2, so times 1.2, and then divided by m, divided by 2. Take a square root of it. All right, so I get, oops, I make a mistake somewhere. Square root of second answer, I get 1.8. So velocity is 1.8 meters per second. Okay, all right, so that's part A. Let's look at part B. Okay, so how fast must a bucket move? Okay, so if a bucket moves very fast, then it's fine. If it moved too slow, what happened? Maybe the bucket ended over here. It may not go for the full circle. It may just come here, swing back and forth. We have to have enough velocity so it can go one round. Just look like the pendulum like this. Okay, if you do not have enough velocity, you would just go like this and swing back and forth. So there is a minimum velocity for it to go around. Okay, so what is that velocity? So in order to go around, okay, or at least to stay up there, we have to minimum have, let's draw the free body diagram when this bucket goes to the top. And by the way, when it goes to the top, it actually look like this. It look like this because this is hanging, so it swing in this direction. All right, when it go on top, if it doesn't come down, that means the centripetal force, okay, that is generated by it will be equal to the weight. Okay, so what should be that centripetal force. The weight is mg. Centripetal force equal to m times acceleration. Okay, that means that acceleration is equal to g. Acceleration, what is acceleration? Centripetal acceleration is equal to v squared divided by r. So it's equal to v squared divided by r. So 9.8 is equal to v squared divided by r. R is equal to square root of 9.8 times r. 9.8 times 1.20. Okay. Okay, so 9.8 times 1.2, and then take a square root of it. I got 3.4. Okay, so 3.4 will be the minimum velocity for it to go around. Less than this velocity, the bucket will not go all the way to the top and go around. It will be just swing back and forth. Once again, the lucky number for this one is 0.